Good evening, sir.
Good evening, ma. Prakash, are there?
Yes, sir.
You missed the physics class, huh?
Yes, sir. I went out, sir. Cold, sir.
We were in school.
Sir.
Okay. But I solved some NCERT problems today, so try to check the video and catch it up.
Okay, sir.
Okay, sir.
Inverse trigonometric functions. So this exercise is over, right?
Yes, sir.
Uh, so any doubt from the previous class?
No, sir.
Is everyone clear?
Yes, sir.
Okay. So those who are here, okay. Shall we get started with the next exercise? I told you, no, that is important for the calculus part. Can I have one textbook? Yeah. See, I'm going to share some ideas here of some substitutions, right? Depending on how the function is, right? I'll be telling you what trigonometric function you can substitute so that you can follow the same procedure in differentiation and a chapter named as integration also. Okay, so it's the same idea. Can I just have a confirmation? Is everyone clear with the concepts of yesterday's class? So write down the next heading as properties of inverse trigonometric functions. So the heading is properties of inverse trigonometric functions. Okay. See, when I spoke about inverse function, the idea of inverse function comes from the concept of composition of functions. So how does the composition happen? It happens either as f circle g or g circle f, among which one of the functions will be sine and the other function will be sine inverse. So one will be trigonometric function, other will be inverse trigonometry. So if at all I take in this order, then what is that we are going to get? Suppose I use this one and operate this. So if I say f circle g and tell me what is the answer, you will say sine of sine inverse of x is what you are going to do, right? Similarly, when you do g circle f, what is it going to be? It will be sine inverse of sine x. So here, one point to be noticed is both will generate the same result of x. This is where we get confused. But the point is, the value of x that is coming from here will belong to the domain of -1 to 1. And the value of x that is coming out from here will belong to the domain of -pi/2 to pi/2, because you need to look at the input function. So what is that you give here? You give the angles. What is that you give here? You give the values. So to put it simple, right? This chapter is only about one thing. What is the kind of input you are giving? What is the output you are expecting? So if you give the input as angle and output as a value, you're dealing with trigonometric functions. If you give the input as a value and output as an angle, you're dealing with inverse trigonometric functions. That's all you need to see. Am I clear with that? So having said this, there are some properties, among which the first property is like this. See, it's given C. First one is sine inverse of x is equal to, or sorry, yeah. So sine inverse of 1 by x is equal to cosecant inverse of x. That is the first property. Remember, I told this yesterday. We can swap and write it. Suppose you have a question of cosecant inverse of 2, it is the same as sine inverse of half. Clear with this? But here, the point to be noted is belongs to what? Where will x belong to? Will it belong to -1 to 1, or look at the functions, right? This will also help you understand the concept of domain and range. Tell me, look at the function. You need to write the domain of which function? Will you write for sine inverse or cosecant inverse? You need to write it for cosecant inverse because x is in the numerator. So x belongs to -infinity to -1 union 1 to infinity. Am I clear with this? Okay. But the important point is, how did this property come? I'll show you the proof of it. See. If suppose I take this cosecant inverse, I write y is equal to cosecant inverse x. Throughout inverse trigonometry, you will follow only one procedure. First, you will take that inverse function and equate it to y. Then you will consider the inverse trigonometric function of it. So for cosecant inverse, what is going to be the corresponding trigonometric function? Cosecant. So consider cosecant on both sides. So cosecant y is going to be equal to cosecant of cosecant inverse x. So f of f inverse x is going to give me x itself. So cosecant y is x. So if I take the reciprocal, 1 by sine y is equal to 1 by x. Right? So 1 minute. No, sorry, 1 by sine y is x. Yeah, you cannot change the values. I'm sorry. Then both will generate same result. So 1 by sine y is equal to x. Am I right? So which implies sine y will be equal to 1 by x. So if you want to remove the trigonometric function, consider the inverse of it on both the sides. So what will you take on both the sides? Take sine inverse. So sine inverse of sine y is equal to sine inverse of 1 by x. So sine inverse of sine y is y. Y is equal to sine inverse of 1 by x. Always, the first step is equation number 1. The last step is equation number 2. They both will be the same. So here y is cosecant inverse x, y is sine inverse of 1 by x. That is why they both are same. Is that point clear? See, this is the method you will follow throughout this chapter, nothing else. So answer will be sine inverse of 1 by x is the same as cosecant inverse of x. So please make a note of this. Yeah. So is there any step that is not clear, or you're not clear with it? Okay. So first step you understood, I took the RHS. Y is equal to cosecant inverse x. So I want that cosecant inverse to get eliminated. What is the trigonometric function I should consider? Cosecant. You need it. So look at this inverse trigonometric function, just convert the normal function on both sides. Cosecant y is equal to cosecant of cosecant inverse x. So f of f inverse of x, according to this logic, is x, identity function. Right? So cosecant y is x. But how can I write cosecant in terms of sine? So I can write 1 by sine y. So right hand side is left as it is x. So 1 by sine y is x means cross multiply. Sine y will be 1 by x. So I want to eliminate this sine. So what is the function I should consider? The pre-function that I'll consider is sine inverse. So sine inverse of sine of y is equal to sine inverse of 1 by x. So sine inverse of sine y is y. Sine inverse of 1 by x, I left it as it is. This is 2, this is 1, equate. Am I clear with this?
Yes, sir.
Yeah. Shall I proceed?
1 minute.
Your copy?
Yes, sir.
Right.
Completed, sir.
Okay. Shall I proceed then? Here, everyone. So the next identity is cos inverse of 1 by x will obviously be equal to secant inverse of x for all values of x that belongs to same -1 to -infinity to -1 union 1 to infinity. That's it. So what will I do? Y is equal to, I'll take the RHS, secant inverse x. I'll consider secant on both the sides. So secant y is equal to secant of secant inverse x. So secant of secant inverse x is going to be x. So secant y is x. But what is secant y? 1 by cos y is x, which implies cos y is equal to 1 by x, which implies considering cos inverse on both the sides, it will be cos inverse of cos y is equal to cos inverse of 1 by x. Cos inverse of cos y is going to be y. Y is equal to cos inverse of 1 divided by x. So this is 2. This is 1. So both are y's. So secant inverse x will be equal to cos inverse of 1 by x. That's it. Okay. Here. Now, shall we take an example and see? See, in the previous case, for example, I have cosecant inverse of 2. If at all you don't know the value of cosecant inverse of 2, what is that you can write? You can write this as sine inverse of half. This is easier, right? Sine inverse of half is going to be, that's the answer. So cosecant inverse 2 and sine inverse half both will generate 5 by 6. In a similar way, if at all you have secant inverse of 2 by root 3, this will be cos inverse of root 3 by 2. So cos inverse of root 3 by 2 is again going to be 5 by 6. That's it. You're able to understand? Right. So go to page number 28 in your textbook. So if you go to page 28, so if you look at example number 3, right? So what are they saying? Show that Sine inverse of 2x into root of 1 minus x square is equal to 2 times sine inverse x for all values of x that belongs to minus 1 by root 2 to 1 by root 2. Okay. This is the first part. Second part is the same question. Sine inverse of 2x into root of 1 minus x square. This is written as 2 times cos inverse of x for all values of x that belongs to 1 by root 2 to 1. Are you able to understand? So LHS is the same part, but how are we getting two different answers on the RHS? Right. So for that, one point that you're supposed to know is with respect to the substitution. So throughout your math, wherever you find 1 minus x square or root of 1 minus x square, right? You will see this kind of function at multiple places. 1 minus x square or root of 1 minus x square, you will put x is equal to sine theta or cos theta. The reason is very simple. Trigonometric identities. So sine square theta plus cos square theta is 1. So suppose I put sine theta here, I'll get 1 minus sine square theta, which is cos square theta. If I put cos theta here, I'll get 1 minus cos square theta, which is sine square theta. That's the logic. Okay. The other kind of functions that you will find is instead of 1, you will have a square minus x square. You will find this also. Or you will have root of a square minus x square. Then x can be substituted as, any guess? Sine or cos is right. You will substitute it as a sine theta or a cos theta. Because when you substitute this, you should get a square, take that a square outside. Are you able to understand? So using this logic, tell me what are we supposed to do here? You will either substitute sine theta or cos theta. Right? So when they say show that, right, since you are getting two functions, right, two inverse trigonometric functions, depending on the right hand side, substitute that value. So for the first one, what I'll do is, for the first one, I'll take this as y. Y is equal to sine inverse of 2x into root of 1 minus x square. I will substitute x is equal to sine theta. If I do this, I'll put it here. Sorry? So x is equal to sine theta. So you substitute it here. Y will be equal to sine inverse of, you tell me, 2 sine theta into root of 1 minus sine square theta. So which is basically going to be cos theta. So it is cos square theta under a root. So what will you get? You will get sine inverse of 2 sine theta into this value is cos theta. Right? Root of 1 minus sine square theta is root cos square theta. You got cos theta. So sine inverse of what is 2 sine theta cos theta? Sine 2 theta. So sine inverse of sine 2 theta. 2 theta. So 2 theta. Now observe, you have put x is equal to sine theta, right? In this step itself, what you should do is, this implies when you take sine inverse on both the sides, right? You will get theta is equal to sine inverse x. I hope you understood. I'm not writing that step in detail. So I take sine inverse on both sides. Sine inverse x is equal to sine inverse of sine theta. So theta is sine inverse x. Always, whenever you do this kind of trigonometric substitution, write the inverse trigonometry in the same step. Right? After you do this, take this value and substitute it here. What will be the answer? That's what they expect. Right? So in a similar way, instead of sine theta, if you substitute cos theta, you will get the second. You can try that and see. I'll give you 2 minutes time. First copy this, right? And then try that and see. Are you here and are you clear?
Sir.
Good. No, that is where it belongs to. So it belongs to the fourth quadrant and the first quadrant. That is the domain of this function, where you will get 2 sine inverse x only when you have the value of x corresponding to the first quadrant. Whereas this one, when it corresponds to the, it is only first quadrant. See, 1 by root 2 na enga varum 45 degrees quadrant ma. This 45 degrees. Inge 1 by root 2 varum. So 1 by root 2 to 1. The values of x is varying between this. In CBSE, will not use this at all. But if you want to learn, you can try thinking in those terms. Right. Only 2-3 problems are there. Where did you find? So once you're done with this, you can copy the, try the next one. Yeah. Cut. 14th. So you can either substitute sin theta or cos theta, will still get the same answer. Yeah, puriyala. Varum same answer. Properties therindha. Did she say minus varum sonnangala? Okay, that could be possible. So here you took this one. So what were you asked to substitute? Sin theta only. So it is because, see, this is the value it is taking, minus 1 by root 2 to 1 by root. Then we need to substitute this. You can take an identity. This actual identity. There's basically an identity of sin to theta and and cos to theta. In the RHS, which I guessed it. RHS into consideration and guess. Got it? No? Yeah. So you substitute cos theta, it will be the change. Yeah, actually, sorry, it's my mistake. It is right. 1 by root 2 to 1, the answer will change. It will be a minus sign. So try the next one and let me know. Done? Everyone got it? Okay. So where is the textbook? So listen. Example number 4. Example number 4. Express tan inverse of cos x divided by 1 minus sin x in the simplest form. So this is another type of problem you will see when they say simplest form, right? You need to eliminate the inverse trigonometric function. You need to eliminate this tan inverse. So listen to this logic. You will be able to eliminate the inverse function only if the inside function is in terms of tan. Because tan inverse of tan can only cancel it. Okay. So what I should do is I need to convert this whole thing in terms of tan. Okay. This is another idea that I'm going to share. Make a note of this. Wherever you have cos x, right? you can sometimes write it as cos square x by 2 minus sin square x by 2. Reason being very simple. What is cos 2x? Cos square x minus sin square x. So this is half angle formula, right? X by 2 minus sin square x by 2, or sometimes you can write it as 1 minus 2 sin square x by 2, or you can write it as 2 cos square x by 2 minus 1. Okay, and some places you will find this 1 minus sin x, and you will find 1 sin x also. Okay, when you find this 1 minus sin x, no, you have to write this as cos square x by 2 plus sin square x by 2 minus, this is there, no sin x. You will write this as 2 sin x by 2 cos x by 2. See, it's very simple, okay? I'm only taking, see, one I wrote it as cos square x by 2 plus sin square x by 2. That you would have understood. Cos square theta plus sin square theta is 1. Whereas when you have sin x, right? Imagine sin 2 theta, it would have been 2 sin theta cos theta. Exactly half of it will be 2 sin x by 2 cos x by 2. So that you take this as A, this as B, then it become A minus B the whole square. It is basically A square plus B square minus 2AB. So it becomes A minus B the whole square. Similarly, there are places where we will see 1 plus sin x. Now you tell me what should do. Cos square x by plus sin square x by 2 plus 2 next sin x by 2 cos x by 2. Then what will be the answer? Cos x by 2. That's the answer. Okay. So I'm going to use this logic here. When I do this, see what I'm going to get is, I repeat whatever I'm teaching here is important for calculus. So make a note of everything that I write on the right hand side. Okay. These are very, very important. More important than the problem themselves. Right. It is more important than problem. The ideas are important. Right. Cos x is what? So among the three, which one should I choose? I'll choose the first one. So I'll write it as cos square x by 2 minus sin square x by 2, the whole divided by 1 minus sin x is cos x by 2 minus sin x by 2, the whole square. Am I clear? So here, what did they give? Yeah, x belongs to minus 3 pi by 2 to pi by 2. No? So minus 3 pi by 2 to pi by 2 means where is the angle falling? So if you break it minus 3 pi by 2 to 0, it's falling in the fourth quadrant, and pi by 2 is falling in the first quadrant. Okay. So cos square x by 2 minus sin square x by 2, what we can do is tan inverse of a square minus b square. You will write it as cos x by 2 minus sin x by 2 into cos x by 2 plus sin x by 2, the whole divided by, this one is cos x by 2 minus sin x by 2, the whole square itself. So this whole thing and one of the values will get cancelled. Makes sense? So what is that you are left out with? Tan inverse of cos x by 2 plus sin x by 2 divided by cos x by 2 minus sin x by 2. What you will do is divide the numerator and denominator with cos. When you do this, you will get tan inverse of cos x by 2 by cos x by 2, 1, plus sin x by 2 by cos x by 2, tan x by 2, the whole divided by cos x by 2 by cos x by 2 is 1, minus sin x by 2 by sin x by 2 will be. So 1 plus tan theta by 1 minus tan theta is a identity. So listen to this. You have this tan of a plus b, no? You remember what is this? Tan a plus tan B by 1 minus tan A tan B. If you observe, instead of tan A, you have 1. So that 1, can I write it as tan pi by 4? Tan pi by 4 is 1. So tan pi by 4 plus tan x by 2 by 1 minus, here you have a 1. 1 into tan x by 2. So can I write it as tan pi by 4 plus tan x by 2 by 1 minus tan pi by 4 into tan x by 2. So basically this is tan inverse of tan of pi by 4 plus x by 2. Answer will be pi by 4. Okay, this will be the answer. So it will be pi by 4 plus x by 2. So make a note of this. One. Okay. So what I did is, logic is very simple, Surya. Whenever you have divided by cos x by 2. Okay. Done.
Yes, sir.
You guys done? Did you make a note of all these things? Right. See, I told you, that this will be useful in differentiation integration. Let's take differentiation for instance. If suppose they give you the function as y is equal to, let's say, tan inverse of cos x divided by 1 minus sin x, asking you what is dy by dx. Okay. If you do it by direct method, it is a tedious process because you need to do the derivative of tan inverse and then the derivative of u by v. It will take ages. Instead, what you can do is, if you use this converting it to simplest form, right? When we solved it, what is the final result that we got? Y is equal to pi by 4 plus x by 2, right? If you differentiate this or if you differentiate this, both will give you same answer. So what will be the answer? Dy by dx, derivative of pi by 4 is 0, derivative of x by 2 is half. This answer. So that is the advantage with this. Okay. Are you able to understand? Right. So there is a fifth example. See, convert or example number 5, cot inverse of 1 divided by root of x square minus 1, where x is greater than 1 in the simplest form. So here, listen to this. 1 minus x square, I told you, we need to substitute x as sin theta or cos theta. So there will be scenarios where you will have x square minus 1 or root of x square minus 1. At that point, at that time, you need to substitute x as
Sin theta or
secant theta or cosecant theta. Need to substitute them as secant or cosecant because secant square theta minus 1 is tan square, cosecant square theta minus 1 is cot square. Sometimes you will have x square minus a square or root of x square minus a square. Then x will be equal to a secant theta or a cosecant theta. Okay. Now observe, what am I supposed to substitute? Actually, I think some property is missing in this. Is this how much they've given your new textbook? Okay. 1 divided by root of, what will you substitute? I want to substitute secant square. Okay. Then, so cot inverse of 1 divided by root of secant square theta minus 1 is tan theta. So 1 divided by tan theta. So what will the answer be? Cot inverse of 1 by tan theta is cot theta. Answer will be theta. But I told you no. So if you substitute x is equal to secant theta, then what is the value of theta? So what is the answer for this? This answer. Okay. So this is the simplest form. So can I say that 2.2 is there, Appa? How will you solve? Okay. This. I hope it is clear, right? Shall I proceed? Deleted idea. Deleted idea. Because as one which is given in CBSE website, it is there. I mean, it is not there. Sorry, it's anyway going to help you only. There is nothing wrong. Initial days of year, then are no problem. Learn it. I'll help you somewhere else. Yes, strike point of full confident. However, she'll tear the page also. Okay, going to the next one. Did I give back the textbook? Yeah, Unita. So we'll do the exercise problems. I'll give you the ideas. Right. So the first one is prove that the first one is 3 sine inverse x is equal to sine inverse of 3x minus 4x cube, where x belongs to minus half to half. Okay. So this is again clear, right? See, you look at the multiplication factor, that will be the multiple. For example, here it is 3 sine inverse x. No, means you need to recollect the formula of sine 3 theta. Had it been 3 cos inverse x, you need to recollect the formula of cos 3 theta. So what is sine 3 theta formula? So if at all you are not able to recollect, you can look at this and tell me. It is 3 sine theta minus sine cube theta. So what are we supposed to do here? Take RHS, substitute x is equal to sine theta. When you do this, you will get sine inverse of 3 sine theta minus 4 sine cube theta. So what will it be? Sine inverse of 3 sine theta minus 4 sine cube theta. It is sine 3 theta. Answer will be 3 theta. But what is theta? You're done. So it is 3 sine inverse of x. That's it. I took from RHS only. See, this is bigger one. No, simplifying this is easier. You can take from LHS and also do, but if we again you need to consider sine, write the formula for sine 3 theta, then substitute it back. Both will give you the same answer. Clear with this? Right. Second, you have 3 cos inverse x is equal to cos inverse of what is going to be the answer? You tell me, no? How is the formula going to be? It will not be, it is not exactly the same format, it is reverse. Look at it, you will look at the question, you will understand. That's it. So it should be 4x cube minus 3 cos theta. Right? So x belongs to half to 1. Now see, again I am considering the RHS. What are we supposed to substitute? X is equal to, you will substitute cos theta, which implies theta is equal to cos inverse of x. Okay. Now substitute it there. You will have cos inverse of 4 cos cube theta minus 3 cos theta. So what will you have? Cos inverse of cos 3 theta. Answer will be 3 theta, but what is the value of theta? Cos inverse of x. That's the answer. Simple. So you can keep copying along with me, right, so that we can save time. Shall I proceed? Listen. So look at the third one. Tan inverse of root of 1 plus x square minus 1 divided by x. Tan inverse of root of 1 plus x square minus 1 divided by x. You see 1 plus x square or square root of 1 plus x square. You need to put x is equal to tan theta or cot theta. Similarly, if you see a square plus x square or root of a square plus x square, you will put x is equal to a tan theta or a cot theta. Okay, take that and substitute it here. So tan inverse of square is 1 plus tan square theta. What is 1 plus tan square theta? Secant square theta. So you will get square root of secant square theta minus 1, the whole divided by tan theta. Right? The tan inverse of secant square theta under a root is going to give you secant theta. You have minus 1 divided by tan theta. See, since you have tan inverse here, mostly you will get something in terms of tan only. Right? How to observe this? It will be tan inverse of 1 by cos theta minus 1. Am I right? So can I write it as 1 minus cos theta divided by cos theta? The whole divided by sin theta by cos theta. This cos and cos will get cancelled. So again, coming to the right hand side, 1 minus cos theta is 2 sin square theta by 2. It's very simple. Okay, why I wrote that? Because you remember for cos theta, I gave 3 values: cos square theta by 2 minus sin square theta by 2. Then 2 cos square theta by 1. Similarly, you have 1 minus 2 sin square theta by 2. Bring it to the left and take cos theta to the right. So it will become 2 sin square theta by 2 is equal to 1 minus cos theta. In a similar way, can you tell me what will 1 plus cos theta be? All these things were there last year. What is 1 plus? It will, instead of sin square, it will be 2 cos square theta by 2. That's it. Okay, so here what should I do? 1 minus cos theta. 2 sin square theta by divided by, what is sin theta? It is 2 sin theta by 2 cos theta by 2, half angle formula. So 2 and 2 are gone. One sin is going to get cancelled. So what is that you're left out with? Tan inverse of sin theta by 2 by cos theta by 2 is, answer is, but what is theta? You put x is equal to tan theta. Theta will be, so answer will be half of inverse x. One common mistake. People write tan inverse of x by 2. Wrong. You have 2 to the whole inverse trigonometry value, to the theta, not to x. So this is wrong. Don't write it like this. It is half of tan inverse x. Is that clear? See, I don't think this exercise is there because you can't solve some problems. For example, 9th and all you can't solve. Without, there is an identity which you need to know. You can't touch it. Okay. I'll just do two more problems, which are simple. Okay, I'm not going to do something like this. I'll do two more problems. After that, you can try the remaining ones. So look at the 10th one. Look at the 10th problem. So what is the 10th one? Sine inverse of sine 2 pi by 3. What will be the answer? Sine inverse of sine x is equal to x, right? So what we write is 2 pi by 3. But this is wrong because sine inverse of sine x is equal to x only if x belongs to, yes, minus pi by 2 to pi by 2. If you observe this value, this is greater than pi by 2. So you need to bring this value equal to or less than pi by 2. So for that, what you need to do is sine inverse of sine of, see, whenever you have, observe, whenever you have the numerator less than the denominator, whenever you have the numerator less than the denominator, write the numerator in terms of denominator. So how can I write 2 in terms of 3? Can I write it as 3 pi minus pi divided by 3? Right. So split the 3 to each part. So sine inverse of sine of pi minus pi by 3. So sine of 180 minus theta is sine theta only. So answer will be sine inverse sine pi by 3. Now you can write the answer as pi by 3. So this is how you solve. So you should not write it as 2 pi by 3. Reason being, it does not belong to this domain. Tejas, am I clear?
Yes, sir.
Cos inverse of? Sine of pi minus pi. Whenever you do a multiple of 180, you will get the same trigonometric function. Sine of pi by 2 minus pi by 3 is cos pi by 2. Whenever you have multiples of pi, for example, pi minus something, 2 pi minus something, 3 pi minus something, it will be the same trigonometric function. Only thing, it will either have a positive sign or a negative sign. That is the logic. If it is a multiple of, odd multiple of pi by 2, for example, pi by 2 minus pi by 3, 3 pi by 2 minus pi by 3, 5 pi by 2 minus pi by 3, and the sign would have become cos, cos would have become sin. And a pi by 2 is complementary, pi is supplementary. Okay, see one last problem. Tan inverse of tan, answer. By default, what do we write? 3 pi by 4, but this is wrong. Why? Because this is greater than pi by 2. So 3 pi by 4 is how much? 135 degrees. Pi by 2 is 90 degrees. It is greater. So what should you do? You should write it as tan inverse of tan of. So you'll write it as, so you can start doing it in mind. Like you need not write it like this always. So it is 4 pi minus pi. So it will be pi minus pi by 4. Pi minus, but this is where we need to be careful. So this will be, this all these are properties again. I doubt whether this exercise is there or I don't know why they have given it, but I'll teach you. Listen, okay. So tan of pi minus pi by 4 is minus tan pi by 4. Okay, you can take this minus outside. That is only for tan inverse. I'm sorry, I'm explaining this without the property because it's not there, but I'll tell you how it has come later. I'll tell you. Okay. So if I take the minus outside, so minus of tan inverse of tan pi by 4. Answer? That's it. Okay. There is a reason why we have to take that minus out. So as I mentioned, right, 1 minute, I will complete. So you can go to the app again. In the pre-recorded section, I have done all the properties individually. I've taught all the properties which are missing in your textbook. I would suggest you to learn them. So yeah, please don't skip that, learn it before the next class. There is a property, tan inverse of minus x is minus tan inverse x. There is a property like this, third property, the textbook is minus tan inverse x. Other way, for example, see, simple ra, sine inverse of minus x is minus sine inverse x. Okay, cos inverse of minus x it is not minus cos inverse x, it is pi minus cos inverse x. Yeah, you have to see. I've explained the reason there. You just go through the videos. Because now I don't have time to teach in detail. So go through them. And next class, make notes and come. Like how you did for inverse functions, right? Make a note for all these properties also. Okay. So shall we wind up?
Yes, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.